index sets. The difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings, they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python, there is only one built-in standard mapping type, and that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So what I have mentioned until now are probably the most common data types that we encounter, or that we have encountered now. The next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming, and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime and as we will during the course of this tutorial, during the course of this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions, where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division, which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division, or the single and the double backslash, is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power of something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. So as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true and false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. If I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did x is say equal to 2 and now y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false. As you can see, since x is 2 and y is 3. As you can see, x and y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if x and y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because x is not equal to y in this case. The next one is greater than. So if I did x greater than y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did x lesser than y, I should get true over here, as you can see. There's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say x is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright. So now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11. As you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course. If I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b, or 6 by 2, and it will assign that back to a. So my value in a should be 3. As you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see if I did a is equal to 7 now, and then b is equal to 3. Now, if I did a double backslash equal to b, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say a is equal to, say, 5 now, b is equal to 2. Now if I do a percentage symbol equal to 2, b, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in a. As you can see, it did a divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide a by b and then give me the remainder and then put that remainder back in a. And as you can see, that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have a is equal to, say, 5, b is equal to 2, and I want to raise a by, if I want to raise the value of a by the value of b, and then store that back in a, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory, essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If a is equal to 1001 and b is equal to 1000 plus 1, alright? If I did a is equal to 2, this is an equality check. Are they the same values? True. Now if I say a is b, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of a. The ID of a gives us some value like this, and the ID of b gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. The is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether, now say 2 in a. So is 2 in a? If it is, it will give me true, as you can see. Is 5 in a? It should give me false because 5 is not in a. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, The standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22 by 7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3, it can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with a radius 3, all I would have to do is use the formula 2 pi r. And to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity is it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, so let's see what happens when we call the math function, math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this is this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be a smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of INF or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus and minus INF, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, like how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or it's and it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass maths.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the largest, it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12, the smallest integer that is greater than minus 12.3. And this should give you 12, minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component. So only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It shall give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So mathematically what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function, and let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is, the details are not important. So this will, I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element. And in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this, math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2. And this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log 2. What this will do is again I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, maybe move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this. And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles, but on hyperbolas. Again, the details you don't have to know the details. You should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be a cos h. In this video, we will learn about conditional statements. And we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if, followed by an expression. As you can see from this pictorial, there's an if statement, there is a expression, there is this block of code which, if you can actually see, is slightly indented to the rest of the code, and then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if this statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression. We move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this, the result, which is, this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consist of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during if this condition is met? Well, this is where indentation comes into play. As you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now, it's very important to understand that this is how indentation is used in Python. In other languages, we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X. And I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for. But it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements, and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here, which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing, and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally, I have one small topic that I would like to share with you is the conditional expressions, or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement, and then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable x, and this what value I'm assigning to x depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to x. And as you can see, if I execute this and check what is an x, you can see adult is indeed an x. So this is a very neat, a very readable, and a very it's probably a more it's a better looking way to perform simple else simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, so I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's a way to, it's like a way to create a placeholder where maybe in the future I might write some sort of a, say a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false, and if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process, and it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop, and then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n, and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times. And each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0 and I print the statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now this while statement, now it might look confusing. Now it says while A. Now what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we do like we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally we have another statement within this block called the pop statement, where we're popping the elements of A. Now as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. And again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1. And as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave